Okay. Okay, 7.1 is on parametric equations. Okay, functions defined by a third parameter or variable t, okay? So call it a parameter t or a variable t, okay, such that x is equal to f of t and y is equal to g of t, okay, are called parametric equations. Okay, okay. Most of the time you'll have the variable be t, but it can be, you can let it be other variables as well. Sometimes you'll see it as theta as well, or as, a. Um, so you could, as long as it's x equals something and y equals something, and it's the same variable, then that's a parametric equation. Okay. 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 As t varies, x, y defined by f of t comma g of t traces out a parametric curve. Okay, number one, sketch and identify the curve defined by the parametric equations f of t is equal to t squared minus 2t, and g of t is equal to t plus 1. Okay. So we're going to get Okay, we'll call this x is equal to f of t and y is equal to g of t. Okay, and we're going to say, well, what's this going to trace out for various values of t? So we have t, we have f of t, which is x, and y, which is g of t. And that's going to trace out various points, okay, of x, y. So let's look at some points here. Let's try -2, -1, 0, 1, 2, 3, and 4. Okay, if I plug in -2 into f of t, I'm going to get 4 minus, oh, sorry, I'm going to get 4 plus 4, which is 8. Okay, y of t would be -1, and so I would get the point 8, -1. Okay, plugging that in. At -1, okay, plug in -1, I get -1 squared minus 2 times -1. So that's -1, or sorry, that's -1 plus, -1 squared, which is 1 plus 2, which is 3. So that's 3. -1 plus 1 is 0. So this is going to be at 3 comma 0. Okay, for 0, we're going to plug in zeros here. For 0, t squared, that's 0, minus 2t, that's 0. So I get 0. And then I get 0, 1 for 0. At 1, I'm at 1 minus 2, which is -1. And then we have 1 plus 1, which is 2. Okay, and so this is -1, 2. At 2, we're at 2 squared minus 4. So that's 4 minus 4, which is 0. So we're back at 0. And then 2 plus 1 is 3. So it seems like the y's are just going up by 1. Okay, or the g of t's. Okay, are each increasing by 1. Okay, 3. If I plug in 3 here, I get 9 minus 6, which is 3. And then y of t is 4. So this was 0, 3, and this is 3, 4. At 4, we're going to get 8 and 5. Okay, at 4 squared, we're going to get 16 minus 2 times 4, which is 8. So 16 minus 8 is 8, and then 5. So this is 8, 5. Okay, so what is this going to sketch out? Okay, when I sketch these values here. Okay, the y's go from -1 to 5. So maybe we'll go like this, where we have 1, 2, 3, 4, and 5, and -1. Okay, the x's go from -1 to +8. Okay, so -1 to +8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay. So we have 8, -1 when t is -2. So we have 8, -1. Okay, this is for t is equal to -2. Okay, when t is equal to -1, we have 3 comma 0. That's here. Okay, t is equal to -1. Okay, when t is 0, we're at 0, 1. So this is t is 0. Okay, t equals 0. And then at t equals 1, we're at negative 1, 2. Negative 1, 2 for t equals 1. Okay, t equals 2. I think we're back to, we're at 0, 3. So we're here. Okay, so t equals 2. And then t is equal to 3 is 3, 4. So 3, 4. Okay, t is equal to 3. And for 4, we're back at 8, but we're up at 5. Okay, t equals 4. So we're getting this nice parabolic shape. It is actually a parabola. Okay, an x-oriented parabola. Okay. And as the numbers increase, it actually gives a direction for which the parabola is traveling. So we can see kind of that it's going in this clockwise direction. Okay, as t increases, it traces out this path of a parabola. Okay, kind of this x-oriented parabola. Okay. We could actually verify that by doing something called removing the parameter. So if I have y is equal to t plus 1 and x is equal to uh, t squared minus 2t, we could solve for t in the first equation by subtracting 1. I get t is equal to y minus 1, and we could plug that in for t in the second equation, and I would get x equaling y minus 1 squared minus 2 times y minus 1. This is x equals y squared minus 2y minus 1 minus 2y plus 2. Okay, if I combine like terms, I get y squared minus 4y plus 3, I believe. So this should be a plus 1, plus 3. Okay, which is an x-oriented parabola. Okay, and this is called removing the parameter. Okay, number 2. Okay, what is a different way to represent the curve f of t equals t squared minus 2t, and g of t is equal to t plus 1. Okay, so we found that this was equal to x equals y squared minus 4y plus 3. Okay, we can parameterize on, the same curve differently. Okay, there is more than one way, more than one way to parameterize a curve. Okay, so another way that we could do the same curve, parameterize the same curve, okay, we don't have to use these curves necessarily, although if we really wanted to, we could let y equal t plus 1, but we could also just let y equal t. Okay, and then that would leave x equaling t squared minus 4t plus 3. So that's a second way that we could actually parameterize we could let, g of t be t plus 5, t plus 7, and whatever we choose for one of them, we could try to make it make sense for the other one. Okay. But one easy way to parameterize when we have an equation already solved for a variable is to let the other variable just be t. And then we get a nice, easy parametric equation, okay, where we could let f of t be t and g of t be t squared minus 4t plus 3. And then we get another set of parametric equations for the same curve. Okay. Okay, so note a curve I should say a unique curve can be represented by multiple pairs of parametric equations. Okay, number 3. What curve is represented by x equals sine 2t and y equals cosine 2t? Okay, as t goes from 0 to 2 pi. Okay, so let's see what this is. Notice that from our trig identities that sine squared of x plus cosine squared of x is equal to 1, right? So I could say that sine squared of 2t plus cosine squared 2t is equal to 1, okay? What does this mean? This means that x squared plus y squared is equal to 1. If I just directly sub in, okay, which is the circle centered at the origin with a radius of 1. Excuse me. Okay. But you could say that of any cosine or sine. How does the 2t change things? That's what I want to know. We have not just a sine of t and a cosine t, but how does the 2t change things? Okay, we have this circle. Okay, if t is equal to 0, let's kind of look at what's happening here. If we go t and then 2t and then sine of 2t and then cosine 2t, right? And we get our x's and y's. Okay, and then we get our x's and y's. Okay, so let's see what's happening here. Okay, if t is 0, then 2t is 0. And the sine of 2t is 0. And the cosine of 2t is 1. So we would be at 0, 1. So we're starting here. Okay, that's when t is equal to 0. Okay, what about pi over 2? What happens at pi over 2? At pi over 2, 2t is pi. Okay, so 2t is pi. So when at pi over 2, when t is pi over 2, we're actually not at 90 degrees. We get shifted faster or around the circle. Okay, if we did pi over 4, we would be at, when t is pi over 4, we'd be at pi over 2. So maybe we'll back it out to pi over 4 and see what happens. So if we're at pi over 4, then we're at pi over 2. Okay, and the sine of pi over 2 is 1, and cosine is 0, and we get 1, 0. Okay, so this is t is pi over 4. Okay, the next one is pi over 2, which is pi. So then this is going to be 0 and 1. So this is 0, 1. Okay, so that's, or sorry, 0, negative 1. Okay, so this is t is equal to pi over 2. Okay, you can kind of probably see where we're going here. T is 3 pi over 4. That's going to be 3 pi over 2, which is going to be at negative 1, 0. So this is negative 1, 0. Okay, and then at pi, we're actually going to be at 2 pi, which is going to be back at 0, 1. So we're here, and then we're back here. So we actually circled around this is t is equal to 3 pi over 4, and this is t is equal to pi. So we actually circled around the entire circle. We went around the entire circle, but we went around it in half the time. So the period for this got cut in half. Okay, that's what the net effect of that 2t is. Okay, the effect of the 2t is that the period of the circle was cut in half. Okay, so it cycles twice. So it cycles twice in 2 pi units. Okay, so if we went around and it says that we're going to 2 pi here, okay, we're actually going to end up cycling once and then cycling another time. Okay, so we cycle once and then we cycle one more time. Okay, maybe I'll put this in black. Okay, we cycle one more time around in 2 pi units. Okay. Okay, due to the 2t. Okay, number 4. Okay, find the parametric equations for a circle with radius r and center hk. Okay. So the equation for a circle of radius r with center hk is going to be x minus h squared plus y minus k squared is equal to r squared. Okay, so what I'm going to do is I'm going to divide everything by r squared here. Okay, because the goal here is going to be to relate it to the sine, I'm sorry, the cosine squared theta plus sine squared theta is equal to 1. I want to relate it to that guy. Okay. Okay, we could let theta be t here if we wanted to. Okay, maybe I'll make theta t, so we're not. Okay, again, sometimes we can let t be theta. Okay. So then how can we relate this? This is going to be x minus h over r squared plus y minus k over r squared is equal to 1. Okay. And so we can say, well, this inside here is cosine t. So cosine t is equal to x minus h over r. And sine t is equal to y minus k over r. If I solve for x in the first equation, multiply both sides by r, I get x minus h is equal to r cosine t. And if I add h, I get x is equal to r cosine t plus h. Okay, that's my first equation. Okay, do the same thing over here with sine. So multiply both sides by r, and we get y minus k is equal to r sine t, and then add on the k, and we get y equals r sine t plus k. And these are my parametric equations for any circle. You just plug in h, k, and r, and that will give you the parametric. That will give you the equation of the circle. Okay, we could write this in parametric form if we want. Okay, f of t is equal to r cosine t plus h, and g of t is equal to r sine of t plus k. Okay. Okay, and that is 7.1.